Okay, audio check. 1, 2, 3. Sounds like we're live. Camera looks okay, and we are ready to roll. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy, where we are building a game with no game engine. We are in the polishing phase, the last bits and bobs to make things clean and nice and smooth. Today we have a fun-filled day planned. We're going to do a tech check, some technical development. We want to report how much memory our executable is storing in terms of embedded binary data. We're going to check for special days. I'm not exactly sure where I want to shove that. So we'll see. Maybe game context, maybe in global namespace. Then we're going to go hunt down a small selection of songs, shove them into our executable, and then build a music player to use those. And yeah, so that should be plenty for today. I did add a couple of items to the to-do list last night while I was thinking. Right now we're just using my streamer logo. I do need a word sleuth logo, so I will probably crank out like the letter W in chalky letter and call it good. On a black background, maybe inside of like a magnifying glass or something. Gameplay, we already talked about this one, but there's a part of me that says release build should not allow animation disable. It's a thing I'm thinking about. I don't know how many games allow you to disable the animations. It is very handy for development. But if I put in sounds but not the animation chunks, it actually can get very strange on timing issues. So it's a thing I'm debating, just hiding the button in the release build so you can't turn off animations. Everybody's running the same build, they're the same things, the same stuff. That's a possibility. Some of our sounds have a lot of trailing silence on them. So as part of waiting for a sound to finish, like sometimes the sequence of actions won't finish until the sound is done playing, even though it's silence. So we need to trim down our sounds a bit in a few places. Some of them really have a lot of trailing silence, so that's a thing we might do. But yeah, we're really down into the nitty gritty. Okay, here's one that we started yesterday. I can build with this option, right? Let me check. Make file. We are building with lib standard C++ being statically linked. And that did fix some of our issues. So right now my current list of dependencies, which I am still required to maintain, are these 4. I only have 4 DLLs, which again blows my mind. If I statically link things, it should just statically link things. But you know, let's build up this list. Blah blah blah. We need this one. Now, I believe that I can get rid of this one myself. I should be able to statically link that one myself. I suspect that these 2 MSys ones I have to link with this, which right now is not a feature that's working. It causes a double definition of a thing, so I have to figure out what's causing that. And that might get rid of these 2. For this one, I'm not sure what that is, but if it's related to the fact that MSys needs it, then fine, this might fix it. but it might not. So I'll have to do more research on that. But there was progress last night. My son was able to run the program on his laptop when I put these DLLs on in the folder. So progress, slow but steady. I did finally get my bank card activated and turned on and have a PIN. So I should, after stream today or tomorrow morning, sign up for the Steam developer. I started this morning, but I was just using my own Steam account, and I can't associate that with the bank account. So I need a new Steam account to set up the Steam developer, sign up to use the company banking information. So that's like a subtask I'll do tonight. I'll set up a new Steam account for business. Create website. I will need to make myself a logo, which I've been working on my own time. So that's coming. Yeah, so we're slowly whittling this all down. Okay. That's not our plan. Our plan is this. I'm just letting you know I've been thinking about it offline. I've been working on a couple things in the background that have nothing to do with code. And we're getting there. Okay. I think we are ready. Here is another question. Nah, it's fine. Okay. So let's get started. I initialize these warehouses in application, I believe. Oops, I was just there. Texture store, font store, shader store. So everything should basically be here by this point. And I think this is where we're going to put it. Embedded data. I want it in megabytes. So static const equals 1024 times 1024 bytes per megabyte. Okay. We don't have any of the warehouses here, so font warehouse, shader warehouse, image warehouse, and the sound warehouse. I think that's it. Okay, log push shaders. Shaders, then fonts, then audio, and then images. I've kind of stubbed this out in what I think is probably the order of magnitude of the size. So, and not the order of magnitude, but the order of size. So shaders probably don't take much space. Fonts take up some. Audio takes up more. Images is going to be our big lift. Okay. Let's just do everything in double. We're going to be dealing with an awful lot of bytes in the millions. So let's total. So in shaders, total equals 0 to start with. And let's take a look at, I think these all have a similar pattern. Shader Warehouse has an entry count. It's less than entry count, plus index. There we go. Woo. This should be very, very similar for Font Warehouse. Sound Warehouse. And the Image Warehouse. Okay. And really, we're not gonna keep track of absolutely everything, but just the main asset. That's the big lift. Oh, let's see. Do all of these. Let's see. Your Shader Warehouse, Sound Warehouse. Okay. Image Warehouse. Every single one of these, I believe, has an error at the end. Okay. Image, and what's the last one? Sound, Image, Font Warehouse, which also has an error at the end. Okay. So plus an entry count -1. Okay, then Shader Warehouse. Get size. What? Of static cast int. No. Shader Warehouse asset for our index. Oh wait, entry count. 8. So I actually don't need that -1. Because this is 8 entries, and we never hit the error code. Okay. All right, so we sum up our total. Easy enough. Do I want an average? Sure. Total module 0.3 F megabytes. Which will be total divided by bytes per megabyte. And then we take the mean, just, why not? Divided by entry count. And that is basically it. This should only happen basically during startup. In development mode. Shader for sound. And shader for image warehouse. Okay, now image warehouse is a little different. We actually have to treat that a little bit differently. It doesn't have size. Although it should. Uh-oh. We give a width and a height of the image. We don't actually give a size. But we should, because later on we are going to compress that data. So we're going to leave. Well, we don't have to leave it. Total width equals 0. Total height equals 0. So we need to add that to our to-do list. Somewhere. Image warehouse should report size, not just width and height. None of these are huge tasks, just things we need to do. Okay. Then our total becomes total width times total height times, there are 4 bytes per pixel. Bytes per pixel. Then we take our total and our mean, and wonderful. Is that it? I think that's it. I don't think we need to clean anything. Oh, we do need to clean for a debug build. Otherwise, we won't see any of this. Kind of cool. That was not as painful as I thought. As I thought it might be. Yeah, the image definitely needs a size, because we will compress that data later. That's one of the reasons we're doing this printout, so we at least know how big things are. And then as we optimize for space, we will be able to measure exactly how much we saved. Ugh, okay. Well, how's everybody doing today? Last night was election night in the United States. That's all over now. There's some final counting, but I don't think that too many of the results are being contested in any meaningful way. Debug. Okay. So our shaders, we're using up a total of not very much. We should put the count in as well. Our fonts reason a quarter of a megabyte? We gotta be using more than that. I wonder if I have an off by something error. Our image data is huge. I don't believe these numbers. I just don't believe these numbers. My whole executable is not 322 megabytes. It's like 55. So if this was like 50 megabytes, and then that was a 5, that would be a lot closer to what I would expect. Uncompressed audio. So let's go take a look at shaders. That's probably the easiest one to check. Actually, let's go to application. I want those counts. For 1. 2. Our shader warehouse says we have 8 textures. If we go look at the sizes, we've got what, 1, 2, 1, 2, 3, 4, 5 kilobytes or so. So 0.0. See, that's not 0.05. So something's wrong. Hmm. I mean, let's get a little logging in here. Shader warehouse, get key, that same thing. Total equals 0. Total plus plus. Bytes per megabyte. Oh, maybe that's not as far off as I think. in some ways. Could now put another total in bytes. Oh. Only I remembered to put in the semicolons. Okay. I mean, I just know that's not accurate because the size. Oh, no. Well. Our debug is 76 megabytes. Our release is 55 megabytes. Which means we're embedding some 20 megabytes of debug data. Isn't that fun? Okay. So just put more details about shaders out. There it is. So those numbers look correct. We end up with 9,000 bytes. Is that true? 36, 51, 69, 70. Yeah, might be around 9. Maybe we just do a quick manual calculation. 315 plus 376 plus 377 plus 963 plus 1799 plus 1551 plus 1879 plus 1802 is 9062. Now that's 9 kilobytes. Which is correct, yeah. And then divide by 9, you get almost no megabytes per file. Basically 1K per file in round numbers. Okay, fonts. Quarter of a megabyte. Let me see here. If I go in to look at the font assets, I'm literally embedding the full file. So eraser 126 plus 60, 35, 73. So it's at 100, 225, 285-ish kilobytes. Yeah, so that's accurate. Audio, what I'm storing has very little to do with the size of the files, but it is about 5.9 and change megabytes. We discard header data and just embed the raw binary data. So the raw sound waveform. That being around 6 megabytes is about right. Averaging a quarter megabyte or 0.3 megabytes per file. Images. This is the part I'm just not sure I believe. Because my executable is 76 megabytes. So how can I be embedding 322 megabytes of image data in a 76 megabyte executable? It makes you wonder. Makes me wonder. Hmm. 18 megabytes per file. Now these are uncompressed. We're going to shrink this later, but wow. Now these 18 megabytes are. I mean, here you can see it. Let's quit out of this. I go into source, and I word count lines for everything warehouse.cpp. You'll see that our image warehouse is 1.5 million lines of code, of basically raw embedded data, binary data. The sound warehouse is 250,000 lines of binary data. So you can see we do have a lot of data. I don't believe images. Width, height, 4 color channels is 4 bytes. So did I do something wrong? Oh. Okay, I know what's going on. Because I was not thinking. This is a me not thinking moment. If I have, let me explain what I did. That was so terribly wrong. A small image. And I have a big image, or bigger image. This is just me warming up in the morning kind of problems here. I want to know the total area of area A and area B. We need to take area width times area A height plus B width times B height. And this is not the same thing as what we were doing, which was A width plus B width times A height plus B height. So in other words, I was finding the area the bounding rectangle of both of these rectangles. Sum of areas not equal to area of union of rectangles. That's basically how that translates. So that's an easy fix. Total plus equals, so this is our total pixels. There. So for the image, we get our width, we get our height, and that's the total number of pixels, which we then add to. Total equals times equals 4 bytes per pixel. That will give us a much better number. Easy peasy. No, that's not where I want to be. Okay, one more time. There we go, 41 megabytes of image data, average of 2.5 megabytes per image. That looks more sane, because that would mean that in a release build, which is 55 megabytes, we've got 42 plus 6 is 48. I mean, it's basically 7 megabytes for the program. All right, so we are measuring things correctly, and it is almost all image data, and then audio data, and then font data. So when we shrink those images, our application is going to shrink a ton, which is good news for us. All right, we don't need to see the individual files. We've basically verified everything we need to verify there. One last run, just to make sure. One last run. Okay. 8 shaders, 4 fonts, 20 audio files, 17 images. Good. Good to go. Journal. Oops. I get my finger on the right key here. Okay. Application now prints out warehouse memory usage in debug builds on startup. Now we will be able to measure how much how much space we're saving. So that's good. That moves us on to checking for special days. If we want to customize music or the doodads, put some special decorations up for a specific holiday, we need to know what special days we got. So this is laying the groundwork for all of that. St. Valentine's Day is always February 14th. Let's do this work in code. Let's do it in global, because sound, games, different scenes will all need it. So we go into source global. What I need is an enum class for holiday. St. Valentine's Day. Okay, St. Patrick's Day, because, you know, the Irish, always love the Irish. Speak a little Irish, it's always fun. Pass out the old Giudich, Konisatatu kind of thing. Equals 2. Easter's great. Independence Day. I am in the United States, so always got to plug your own country, right? Little national pride, never hurt nobody. And then talk like a pirate day. So that gives me 8 holidays. One I considered is New Year's, but like I don't feel it so it's kind of like a school classroom, right? And we would have Christmas decorations before Christmas, but like then you didn't come back to school until after New Year's. So it wasn't really a thing in the classroom to have a New Year's decorations. And what would I even do? Like fireworks? Dropping a ball off of like all of the New Year's things are kind of not as culturally homogenous. I don't know. Okay, let's add some quick notes. February 14th. That's all we ever need to know. St. Patrick's Day. It's always in March. 17th of March. Easter. List of hard-coded dates for 50 or 100 years. Independence Day, easy. July 4th. Halloween, easy. October 31. Thanksgiving, we're going to have to do a hard-coded list there as well. Christmas is easy. December 25. And then Talk Like a Pirate Day is what, September 19th? Talk Like a Pirate Day. September 19th, yes. Any other holidays we should consider? That's 8 holidays. 2 of them are going to be a big pain in my rear to figure out. Do I even think my game will be around for 50 or 100 years? Doesn't matter. It's a small amount of memory to check. Okay. Easter is March and April. Thanksgiving is always. Okay. The other thing we need is none. Most days of the year are not a holiday. Every other day. Now, get holiday. Comes in before version. It's actually a top hit. Look at that. Okay. Now we need like a date time thing. C date. Oh wow, okay, that's not at all. Okay. Global, CSTDIO, and C time. We get our now. Struct TM, given our local time. Where else am I doing this? There's one place where I'm doing this in replay. Get our local time from now. Then we use year plus 1900. That makes sense. That's a plus. Month plus 1. That'll be a thing. M day, month day, the day of the month, is really Thanksgiving. Could I derive Thanksgiving from the year? Maybe if I knew the day of the week. Take time. There we go. Okay, we only don't need to check the year most of the time. Unless we're in Thanksgiving. Unless we're in November. And okay, well, we can check the easy ones. That's not what I wanted to do at all. There we go. Okay. Dun, dun, dun. St. Valentine's, St. Patrick's, those are easy. Independence and Halloween are easy. Christmas and Talk Like a Pirate Day are easy. Easy, easy. Is there a private? There's not really a private, is there? Okay, we can make one. Enum class month. January equals 1. You know what? We don't need this offset. We'll do 0 next, as intended. January, February, March, April, May, June, July, August, September, October, November, December. Has anyone noticed just how screwed up the calendar is? It's actually kind of incredible. If you look at it, January, February, March, April, all come from, I think, Roman calendars, right? That's Janus and Mars, which is, of course, Aries, and April was, I don't remember where these ones came from. Then you get to the stupid emperors. You have Augustus Caesar inserting a month for himself. You have Julius Caesar inserting a month for himself, which means that September, which should be the 7th month, September, 7, is actually the 9th month. And October, which should be the 8th month, is the 10th month. And November, right, because of the word parts, oct means 8. Nov is for 9. But it's not. It's the 11th month. And December, which is the 10th month, December decimal deck 10. That's actually the 12th month. So I don't remember April, May, June. Are those also Roman gods? Anyway, the fact that they insert themselves before the numbered months, 7, 8, 9, 10, to make these numberings incorrect, that just cracks me up. And the days per week are, of course, mostly from Norse gods, which is super weird. Super weird. Okay, whatever. Oh, yeah. So, if month equals you know what, let's cast it here. Month, static cast to a month, or month. If month equals February and day equals 14. Boom, easy. February, March 17th, St. Patrick's Day. Independence Day, July 4th. Halloween, October, day equals 31. All right, November gets complicated. Therefore commented out. Christmas is easy though. Oops. December 25th. You know what? We're gonna do both Christmas Eve and Christmas Day. Or day equals 25. For 25th, if it's December 24th, 25th, that's Christmas. And then talk like a pirate days, of course, September 19th. And therefore probably should come in before October. There we go. That's a pretty good smattering of holidays, right? Equals March or April. This actually gets a little bit complicated around here. Check for Easter, check for Thanksgiving. Okay. We can test these ones a little bit. Const char star month names equals just for my own logging purposes. Easy. And I also want the holiday names for logging purposes. Okay. Does application use global? It does. Perfect. So I don't have to do anything special there. If we're in debug mode, you can also log the holiday. Oh, we don't need to be in debug mode for that, do we? We can log it. Global. Log our holiday. Void log holiday. How do I feel about that? A couple different options of ways we can go with this. For example, I could just pass a flag into this. I think we'll just duplicate all this work. We want to log it. It needs to happen once. It's okay if it's duplicated. It's fine. Modulus 04B here. So many different formats to choose from. We're going to do month name. of static cast to an integer the month. Month, day, year. And then holiday names of the result. Okay. Let's make sure that we get nothing. Hey, Dravest, doing good. How are you doing? We are in the process. Oh. We're in the process of getting special days in case you want to have decorations or play specific music. Got my little list of holidays here. Valentine's Day, St. Patrick's Day, Independence Day, Talk Like a Pirate Day, Halloween, Christmas, Easter, and Thanksgiving. I think those are the core ones, the main ones that have good visuals, good things like that. These are very United States centric holidays, but you know what? I'm not supporting the world. I'm just supporting myself. What I think is fun is what I do. So yes, anyone playing my game will get turkeys on Thanksgiving, United States Thanksgiving, and anyone will also get their old 4th of July, United States Independence Day celebration. Great. Wow, typo. Unused variable year, it will be used. Don't worry about that. We'll get there. Thought we did that already. We didn't get that one, I guess. Oh. What? Oh. I know what that's about. We copy pasted. Doing good as well. Very tired yesterday. Today you feel well rested. Good. Yes, yeah. Whenever you have one of those dragging days, it's just it's so sad. You know what we're gonna do? We're gonna do this. We're gonna get our current holiday. None. We're gonna change things just a little bit. Compute holiday. Now logging the holiday gets rid of all this junk. Oh no. It doesn't get rid of all this junk. Let's get rid of this junk though. Month, day, year. Current holiday. So we're going to compute a holiday, get a holiday, and log a holiday. There we go. Now application on startup will always compute the holiday and then log it. That makes more sense to me. Result. Hello, InsMod32. Welcome to the chat. How are you doing? Let me know if you want a full spiel on what we're doing here. We can either give you like the project overview or details on our current efforts. Usually I just code string of consciousness, and then if talk stream of consciousness while I code until somebody asks a question in the chat or makes a comment. So feel free to jump in anytime, and I will address whatever questions, comments, or concerns or suggestions you have. Brief overview. We're building a game with no game engine, so I have 4 dependencies that I've allowed and wrote everything else myself. We are feature complete. It's playable, it's done. We need to do new art, we need to put in some sound. Working on a few last loose ends to polish and make things nice and fancy. And what we're doing right now is we're checking the date for a special number to say, do we put up special decorations and play special music? That's kind of where we're at right now. But we document everything we do here in the journal. We've made some decisions. Checked in application. Result lives in global. So that's what we're working on right now. This morning we already are outputting now our memory usage for the embedded data we put in. So we take our image data and we store it in the executable itself. So we're measuring that now. Yeah, things that we're working on. What do you use to draw in the window? OpenGL. So a full list of dependencies can be found right here. So we're using GLEW, which brings in GLFW. Or is it the other way around? I think FW brings in EW. So it's the function wrangler and the extension wrangler. Anyway, we're using OpenGL, and I've hard limited myself to version 3.3 with no extensions, just so that I don't sidetrack too much. Like, this whole project is about narrow scope, right? All I want to do is get something out, get something done, start to finish. The next game will be better, but for now we're like limiting ourselves. So to stop myself from playing with shaders all day, OpenGL 3.3, bare minimum. We are using GLM for our next game. We'll get rid of it. GL Math. This is such a heavy lift for what we're using it for. Basically, just using it for the camera transforms, for the transforms and for the camera perspective, which in our case is orthographic, which is trivial. So way over lifting here. Free type for our font rendering. I want to get rid of this one too. There's a lighter weight version that I may pull in on the next project. Or maybe we write our own font renderer. That could be kind of cool. But I'm happy with port audio for our sound. And then, yeah, you can see we're embedding 41 megabytes of raw image data. So that's kind of where we're at. And in our to-do list, we'll eventually get around to size optimization where we're going to shrink. So right now we're embedding, we're taking PNGs, we calculate every pixel and shove that into our executable. So we're storing uncompressed image data, right? So it's every pixel is 4 bytes, and we're storing every single pixel. But we're going to use a QOI compression once we get around to it. sound. I think most of our sounds have duplicate and left and right channels, so we can, not store both. We don't have to store 16-bit PCM. We might store MU-law encoded. So we're going to shrink things down a bit. Maybe we'll play with some other compression things, blah, blah, blah. But we're going to shrink that executable size down quite a bit here towards the end. So yeah, lots of things to do, but we are in the last steps. So there you go. If you have any questions, let me know. Technical, project-wise, unrelated. I'm just here to chit-chat, to talk, and code. Impressive. Thanks. I think I'm not a game developer. This is basically me trying something new as a learning experience. And I think it's turning out pretty good considering I had no idea what I was doing. And we've learned a lot. Like this to-do list, here's a bunch of tasks that I want to do to make things better, but are out of scope, right? Things are working well enough. We don't want to get stuck in all this tech and tech debt that we would like to do. So we'll have plenty of things to do after the first game before we start the second game. I always figure, if you look at Blizzard's trajectory, a couple of small games, World of Warcraft, Warcraft 2, then World of Warcraft and StarCraft 2, right? Those are StarCraft and StarCraft 2. They grew up to being a huge gaming empire. But then you look at Amazon Game Studios, and they're like, we're going to make the World of Warcraft killer for our first game. Well, they had 2 games queued up, and both of them were similarly ambitious. And where are they? So if you start too ambitious, crawl, walk, run, right? So that's what we're doing. Keeping the scope low, keeping it simple. Every single line since, May has been on stream. So I'm not coding off stream to get things done, mostly. I think there's a few minutes a month or two ago where my stream died, but I just finished my thought and it was too late to restart the stream. So you missed out on 9 minutes of coding there. So yeah, it's amazing what one person can do if all they do is work on it. So yeah, that's the high level overview. Again, let me know if you have any questions. Always happy to chit chat about anything. Otherwise, I'll just go back to streaming, stream of consciousness and coding. Where was I? Oh, it just compiled, so we're going to run a test. So the game is a simple word deduction game. So November 6th, which is correct. Holiday is none. Okay, so that's at least doing that right. So here's the game. I guess I can show you that while we're here. So, ooh, interesting. Proud lines, therefore the letters M-A-C-H-T don't exist in the answer. Edie, flogs, jacks, waxed. Okay, so it's W or X is where my last letter lives. So S is in, L and O are out, D is out, E and N are in, R has to be in, no U, and no P. Okay. So wrens. Boom. And now we get less guesses. So that's the game. Simple. Need to sleep now? Okay. Thanks for dropping in. Feel free to drop in. And yeah, thanks for the follow. You drop in when you're feeling a little more awake. And yeah. Welcome, welcome. So November 6th holiday is none, so that's fine. So we're going to fake a few just to force it. Not fancy, global. So we're going to fake a few. We're going to say month equals February, day equals 14. Quick little compile. And it says it is St. Valentine's Day. Cool. Independence Day, St. Christmas. Talk like a pirate day. Okay. Get those names cleaned up a little bit. All right, so we said February. Let's do March 17. We'll just verify each of these works. Because the tricky one is Thanksgiving and Easter. Thanksgiving, I might be able to do without a fancy schmancy array of values to check. St. Patrick's Day. Okay. March. So July 4th is Independence Day. Independence Day. Correct. September 19th. Oh. Guess I don't need that. Okay, Talk Like a Pirate Day. October 31. Is Halloween. And then Christmas. We're allowing 2 days for Christmas because it is my favorite holiday. 24. And we'll check the 25th. Christmas, 24th. And the 25th. On the 26th, we go back to normal. Okay. And just to verify that, we go to the 26th. Yeah, no holiday on the 26th. Okay. So I would say those are all working. The tricky one now is November. Can I get the day of the week out of this TM? I don't remember what's ever in a TM struct. TM struct. Seconds, minutes, hours, Day of the month, months since January, years since 1900, days since Sunday, so it's W day. Okay. Weekday. So Sunday is 0, Monday, Tuesday, Wednesday, Thursday. So the 5th day, right? Sunday, Monday, Tuesday, Wednesday, Thursday. So it's the 4th day, because then it's Friday, Saturday, 5 and 6. So I think it's the 4th one we're looking for. Date time equals 4. And I need to know if it's the 3rd Thursday of things, right? So here it's Observance United States, 4th Thursday in November. So how do I find out if it's the 4th Thursday of the month? This is a Thursday. Do we just divide the day of the month by 7? And then it has to be between something. So let's just check this out. We can do this in just like a scratch buffer, right? Scratch buffer. Divide 1 by 7. How many we got here? 19, 20. Okay. Three dot 0, 0. Eight 29. 29. 30 days in September, but in November, so we need 31 for November. Okay. Run a little calculation. And then we decide if Thursday is on the 1st, it would be 8, 15, 22. So basically we're looking for anything between 3 and 4, 3 inclusive and 4, right? Day of the month. Oh no, it has to be greater than 3 let's see here. If the 7th day of the month is the first Thursday, right? Then it's 14, 21, 28. So it's greater than 3, less than or equal to 4. I think that's the answer. Float week num equals our day divided by 7. If our week number is greater than 3 and our week number is less than or equal to 4, then the current holiday is Thanksgiving. 4th week. I think that's it. That may work. So if I fake this year's month equals month November, and our day I can't fake that as easily. Maybe we do just throw in the weekdays, right? Why not? Weekday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we are off. It is 0 index, so oops. Sunday moves up. Renumber. So let's get our weekday. There we go. Now we can fake things. We're going to lie. We're going to say if the month is November, this year, November, Thanksgiving is the 22nd this year. And I'm going to just lie and say the weekday is Thursday. So this should trigger this to say it's Thanksgiving. And then we can test against next year and the year after a couple of different things just to make sure our math is right. Yeah, oh, yeah, that's true. Weekday, Thursday. Now we don't need a comment. Even more clear. So in theory, this should... What? Oh. Yeah, abbreviation. Year is still not used. That's fine, because Easter will use it soon. Okay, so we run it. And we do have Thanksgiving on November 22nd. We've hard-coded it. We're ignoring that. We can change the day. And we're still lying to it about Thursday. But it should not be Thanksgiving, correct? If we go 22 and we don't lie about Thursday, That should also not be Thanksgiving. Correct. So just for fun, I'm going to go to 2025, November 27th. Let me lie that it's Thursday. So I don't even need year for November. This is not too bad. I thought November would have to be hard-coded. Only Easter. Okay. So November 20, what did I say? 20, not 22nd, 27th on a Thursday. It is Thanksgiving. Okay, so that works. We only need this weekday in here. Would be kind of useful. Pick a year, run through the entire calendar, and just see what all the results are. Let's get through Easter. Let's get through Easter. Easter, I don't think there's a nice mathematical way to compute it. Let's see. I'm gonna close some tabs here. I've got too many. Oh, that's not interesting. I remember if I linked that one in my notes. Let me check my notes real quick. Regarding linking. Let me just save these notes by myself. Okay. Blah, blah, blah. Okay. So I think November's good. It's Easter that's going to kill me. Let's go look up how to compute the day of Easter, and it has to do with the equinox is, no, solstice, right? Solar cycle. Calculate the day of the year of the vernal equinox. Lunar cycle. Oh, jeez. The year of the century, the lunar parameter, the seed of the first full moon in spring, the calendar correction amount. Jeez. The Easter border. The first Sunday in March. The Easter distance in days. Even this calculation doesn't look right. This must be one of those AI generated responses because it's not taking into account skip year properly. It's just saying year divided by 4. But not every year that's divisible by 4 is a multiple, is a leap year. Ones divisible also by 200 are not. Are skipped years. So the year 2000, for example. I believe the year 2200 will be the next skip. Easter distance in days, the date of Easter Sunday. That goes out to this calculation method goes out to 2,100. Oh, so I guess it's for every 100 years we skip leap year. Maybe do we just try this? Do we just? Ooh, how bold are we? Ah, why not? Right? Why not? Okay. The year. We have the year. The century. Lunar parameter. Yeah, let's do this. Year, century. Y modulus 19 is the lunar parameter. Int d equals this. 19 times n plus 15 mod 30. Calendar correction amount. D over 29. Integer division is 5 plus D over 28 plus D over 29 times n over 11. Easter border. I'm not gonna lie, I did not expect to be doing this today, but you know, I didn't realize there was a simple equation for this, so. Easter border. Plus 2 mod 7. It's the Easter distance. In days. Your century lunar parameter. All that makes sense to me. These divisions are integer divisions, that's fine. This right here is exactly why we can't do anything past 2,100. Valid for Easter checking until 2,100. C for first full moon in spring. Lunar parameter, Easter border, first Sunday in March, Easter distance in days. Which Determine the month and day of Easter Sunday using the ESM if ESM is less than 31, March 31st plus ESM. Ugh. We can look up a list of dates for Easter to double check against. That's nice. Theory. Easter cycle groups days into lunar months, which are 29 or 30 days long. There is an exception. The month ending in March normally has 30 days, but if 29 February of a leap year falls within it, it contains 31. Oh, for Pete's sake. 12 synodic months in a lunar year. Yes, tabular methods. Oh, interesting. Is there not an algorithm written down here? Algorithms. There we go. Gauss presented this algorithm for calculating the dates of the Julian or Gregorian Easter. Peter Tittle pointed out that P was wrong in the original version. Ugh. Okay, so this is different. That's Gauss's algorithm. Anonymous Gregorian algorithm. A New York correspondent. This looks like what I would expect. So we can use the Gaussian method. There's a Mias-Julian algorithm. Oh, Julian. It's not Gregorian, so that doesn't count. Meaus-Jones-Butcher algorithm is the one we're looking at, I think. N is the use this one. It's choppy chop chop. At least we have a reference this way. A equals year modulus 19. B equals year divided by 100. C equals, which doesn't have anywhere near as many explanations. C equals, what? Well, y over 100. Okay. Year modulus 100. So that's the year other than. Okay. And D equals B over 4. Integer math is fine. E equals B mod 4. Now this thing is telling me that F expression goes away. And G, it's a different, so int G equals 8B plus 13 all over 25. Integer math is fine. Int M equals A plus 11 times H. Where's H? Oh, we didn't get to H. Why did I skip H? Equals this mess. 19 times A plus B minus D minus G plus 15. Modulus 30. I int F not needed. I is C over 4. Integer math is approved. Then we get M and N. M. A plus 11 times H plus 19 all over 433. That's our year. O is dropped. Variable N indicates the month of the year. The day of the month is obtained as O plus 1. Post a version with a few changes. The variable G was calculated using Gauss's correction, eliminating variable F. That what P is a correction? Yeah. So O is not needed. This is those correction factors, therefore int O equals H plus L. I don't remember calculating an L. Or a J or a K. Where's K? Oh. I. K is C modulus 4. So H plus JKL, let's get L, is this mass here, times E plus 2 times I minus H minus K modulus 7. Oh. Yes, H plus L. Well, it's not O, it's P. H plus L minus 7 times M plus 33 times N plus 19 modulus 32. That tells me, so given the year, I can compute a date, given, which is N and P. I'm reading this right. Or N, M, and then N. Okay. N is the month number, one indexed. Day number, month, let's see, your day number, also one indexed, right? For 132. It's also one indexed. Okay. So our years are input here. We get out N and P. Now, if, let's see, the month number we've got 0 indexed, and our day, we are also 0. No, M day is not 0 indexed. It is 1 indexed, right? We don't fudge any numbers. I should get today's date. Oops. Oh. Problem with copying code off the inter-Googles. Okay, mod. Unused variable P. That's fine. When we run this, we should get today's date, November 6th. Okay, so the day. Okay. If N equals static cast to a month n plus 1 minus 1. Equals our month. And our t equals today's day. Then we're in Easter. Okay. So let's try that, and then we'll fudge a few dates just to test it out. I'd rather not store a big table. Okay, holiday is none, so that didn't break anything for today. But now if we lie, in theory, if we put in the year 2024, 31 March, and it should be a Sunday. Insert this thing equals weekday Sunday. Right, we gotta fudge some numbers. I'm gonna say it's Sunday. I'm gonna say our year is something. We have 2024. Should be on March 31st. That's one test. Another test will be 2025, which is on April 20th. All right, brief restroom break before we test. Just a moment. Okay, we are back. Now, let me think. Where am I? What am I doing? What am I doing? We are testing. We're going to test 2024. It should be March 31st. Do I have a calendar up still? No. Calendar 2024. Should be March 31st in theory. Weekday was not declared. Oh. We're going to suppress that for now. And fake that. Okay, we're using weekday in a couple of places. Let's just grab it. We should have for Thanksgiving and for Easter, so let's put it there. Okay. 2 colons. There we go. Okay, so holiday is Easter. So if I go the day before or the day after, it should not be Easter. Yep. All right, let's check the 2025. I believe I can get a list of dates for Easter. So we should be able to test a few out, just to make sure that it doesn't fail for the first few years. Yeah, okay, so the day after is nothing. Oh wait, what? 2025, April, oh. This all has to go before the calculation. Yeah, we can test forward a few years. Okay, in theory, April 20th is it. Go retest March of this year. What a fascinating little algorithm. I never knew there was such a simple solution. I mean, not simple in the fact that it's... Oh, if searching failed. Oh, I commented it out. This line. Let's go ahead and get 2026, April 5th. Queued up. 2026, 2027, March 28th. This one passed. That one passed. Let's go 2026. Nope. 2026, March 28th. Oh, 2027 is the March 20. Wait, what? April 5th, 2026. 2027 is March 28th. Okay, so I haven't tested this one yet. We need to test this one. Okay. So our 2026 is correct. We just got the 3030. And it doesn't even have to be on a Sunday. Okay, 2027 works. Let's go to 3030. That's probably enough testing. Who's going to be playing my game in 3031, right? 30, 27, 28 is April 16th. April 1st. 30. April 21. All right, 3 quick tests, calling it good. 2028. All right, 2028 passes. The reason the date hasn't been from November 6th is when we print the holiday, it recalculates its own year, day, month, so it's independent. 2029. Uh-oh. Oh, is that April 1st, 2029? Yes. So I didn't delete that one. There we go. And let's test 2030. Looks good. All right. I think we're done then. Okay. Let's move this up here. Next month equals November. And if our weekday is Thursday, simplify, compute our week number, and go. Check for Easter. Done. See, like, even show up in any of these? Okay, shows up for I and K. I is used, K is used. E is used. Okay. Super cool. We've now got holidays. Compute holiday, get holiday, and log holiday. Awesome possum. I guess that's it, right? Everything else that needs to can get access to global. It is being initialized on application loadup. Before the scene manager loads a scene. Yeah, we're done. And it's all with math. We didn't even need we don't even need a table. We're so clever. Look at us go. Journal. Actually, let's see here. Normal day. Calculated from Wikipedia. Calculated if November Thursday. That's basically it. Compile. We're setting the groundwork. Setting the ground. Okay. Journal. Application now plus global to compute the holiday, log it. Anything can then access the holiday. No, that's not quite right. That's not how we want to do it. Lies, all lies. I want it on every scene entry. Login application. Or rather, we're just gonna get holiday. Okay, we're just gonna get holiday. We're just gonna always log it. It'll be fine. Is that true? Okay. So we need global. Scene. Depends on the scene. So each scene actually have to implement it themselves. So main menu. Hmm. Void init elements. No, it does not allow that anymore. So let's go back here. Okay, the reason we're doing this is because we can now do global get holiday. And not use it for now. Let's suppress the warning. Because the game per scene will need to do some different things. Main menu, about scene, similar issues. Ooh, heyo. Nova IE. Welcome to the chat. How are you doing? What's new? Oh, thank you for the follow. Hopefully you're finding it entertaining, interesting, useful. It's not exactly a prepared, scripted kind of development effort, but I can't think there's plenty of that on YouTube already. So you can watch the good, the bad, and the ugly as we build a game with no game engine. Let me know if you have any questions, because otherwise I just tend to stream of consciousness talk while I code do layout. There. Read about scene. You know what? Maybe we do Maybe we do put it in the base scene. Let's see here. We have access to this thing and the scheduler, so we can go holiday and holiday. Maybe that's what we need. We need that in the protected area. That's better. We still need to clean this up anyways, so that everything is in init and elements, because init and layout need to care about which holiday it is. Okay, so that's main menu about settings scene. Wait. Yes. Settings scene. Init elements, we already have one. Set camera, what is that doing there? Init elements. There we go. Okay. Okay, I see. Okay, setting scene. Game scene, I know has an init. Key press handler, mouse press handlers, fine. Replay stuff. Init game elements. Do layout, okay. High score scene. Uh-oh. Do layout. Void init elements. Okay. What else have we got? New high score scene. Okay, everything's very much the same as it was before, but now we have a date available and we've broken out element initialization into a function so that when we do start checking holidays, it'll be fine. Scene. Game holiday. Is that that'll also determine like our music playlists, doodads, extra little textures we're gonna throw on things. Why did I put a game holiday that's global? Yeah, okay. Much better. And every scene now just has a holiday on load in. So if you leave your game open overnight, and you come the next morning and you click to go to a different scene, it'll update the holiday in the scene. Perfect. So let's run that. Main menu, holiday is none. Play should recheck the holiday. Yep. Okay. Cool. Quit. All right. Oops. Scene now computes and stores a protected global holiday on scene construction. Okay. And most of those just seem to work, so that's it. Add everything. Oop, nope, 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 nope. Source. New high school scene. Okay. Underscore holiday available in every scene automatically. Perfect. Okay. Now we're doing music player. Switching over to music player. Okay. Okay. Oh. All right. Songs. Songs. And really, I just need a small handful of short songs to develop against. They will all be replaced when the new music comes in. Where am I at? Okay. Well, well, well. Okay. All right, let's see. Maybe I should. Oops, don't. Move this over here. Share the old browser. Then we can come over to Pixabay. And there are some songs. We don't really want long ones right now. So if this is showing up okay for you. Whoa, that's loud. That's loud. Yeah, that's not bad. It sounds like it would be a good, like, Halloween one. Epic background orchestral music. I guess let's grab a couple here. We said Midnight Quirk wasn't too bad. It's like a. We're not going to use this in our final product at all. Something wasn't too bad. Piano music. It's not too bad. We can stick with that. Background orchestral. Corporate advertising music. Relaxing piano music. It's 2 minutes long. Power is you. Nope. Interview background. Silent Night. Oh, I like Christmas. We will have to use this one as a test against our music playlist. Lunar Tides. There we go, little synth wave. Relaxing piano music. I feel like I've heard this before. That's long though. This one's not as long. Where have I heard this before? Like a background of another YouTuber or somebody's like animation or something? I don't know. Hmm. A little long. We just want nice short bits so we can hear the random number generator working. Brazilian funk. Yeah, no. Upbeat advertising. Why is everything so advertising? Lo-fi study. Oh, Chill Hop. Yeah, no, probably not. Price of Freedom. $2 minutes. Oh, we wish you a Merry Christmas. There we go. Basically, for a good playlist, we need at least 3 songs just to test against. Elysian Embers? Sounds cool. Shh. 2.5 minutes. A little long. Together We Thrive. Nope. Halloween Trap. On that first page, there was kind of a good Halloween sounding one. Maybe we go back there real quick. I'm looking for short songs. I'm actually looking, let's see, at the page 4. So we'll come back to page 5. Which one was it? Did I already get? Oh, geez, the page reloaded my volume. Nope, not that one. What was it? Night Whisper? Yeah, this one sounded like a good Halloween one. Okay, now we go to page 5. Nope. Future Bass. Just relax. Oh, wait, we're looking at lengths here. 130, Better Day. Oh, let's see here. Countdown Dramatic. Let me see here. It's kind of intense. Um, Maybe that would be a good music, like Halloween one. Ambient piano and strings, a little long. Horror spooky piano. Okay. Ode to Victory. It's like 2.5 minutes. Wow, that's very loud. This Calvin guy's pretty good musician. Maybe we do just grab this one. Let's grab this one. Just need something to develop against, right? Risk. Piano moment. No, it's 4.5 minutes. Nobody needs that. Nope. Serene Horizon. Very long. Okay, okay. Let's see here. feel like I've heard this before. Fall, no. Deck the Halls, there we go. That'll get us our 3 Christmas songs. Uh-oh, what's going on here? My internet looks okay. My internet appears to be fine. Reload the page. Do you already have Deck the Halls? We have... We Wish You a Merry Christmas and Silent Night. So this one will work. I get to start 3 Christmas. Background orchestral for Halloween. Sure, why not? Some less than a minute. Carol of the Bells. I've always liked that song. Okay. Oh, Walter Tchaikovsky. Good old Swan Lake. Yeah, no. Blue Skies. That's 4.5 minutes. Positive Rock. Sure, why not? That's 1.5 minutes. Sure. It's 1.5 minutes. That's about right. All right, this last page. We can go through one more. Got some decent piano music going here. You'll see why in a minute. What we're going for here. Not in a minute. It'll take me a little while. Happy piano music. A little long. Halloween Trap. All right, last page. Disagree. Got plenty of Halloween. Christmas Party Time? Sure, why not? Never have enough Christmas music, right? Twilight Hustle. Funky. I don't think we have this one. Sure, why not? It's 1 minute. No problem. Futuristic beat. Historical documentary background. No place to go. A little long. Deck the Halls. I think we've got Deck the Halls. Deck the Halls, we do. Morning Garden, let's see. Okay, so I think we've got enough songs. Therefore, browser, turn that off. Okay. What we're gonna do is we're gonna stuff all of those into my player. put them in. Oof. Well, oh, these are MP3s. These are MP3s. So I have to format shift every single one to a WAV file, 16-bit PCM 44100. Dang it. All right. See, this is why developers wish they had artists and musicians and people to do the parts they're just not that good at. Okay, so let's go format shift those suckers. Well, copy. I'm gonna move them into my somewhere else. Let's see here. That's this. Music downloads MP3. You should move them here. Music downloads WAV. Okay. Then I'm going to get Audacity, and then we can share Audacity. Because we do need to format shift these. While I keep track of which ones were intended for which playlist. Okay, so I've got Audacity up. Let's share Audacity. There it is. Okay. Users to go, downloads, music download MP3. There we go. We now have a list of these, which I can put into here. Because we need music lists. For what I intend to use them for. We've got a couple of holiday ones, we've got some piano ones, we've got some rock ones. Which should give me 4 playlists, right? Songs.org. Okay. Okay. Boom. Nope. Name, theme, or whatever group we want to add it to. Okay. All right, so let's get Carol the Bells in there. So this is obviously Christmas music. Export as WAV into somewhere else. Wow. Okay, the dough downloads, music downloads WAVs. There we go. Okay. Hold on. Let's go through that again. File. So we've got 44100. Yes. Export as WAV. I forgot to check that. 16-bit PCM and Put it in the WAV folder. Boom. Right, there's one. And then this one will be Christmas. Christmas party time. Where did my Audacity go? It's hidden behind something. There it is. Okay. All right. Christmas party time 44.8. So we need to downsample that just a scotch file. Export as WAV. Sign 16-bit PCM into that same folder. Perfect. And this one is also Christmas. Well, okay. And then we close this. We get the cinematic, dramatic, sad piano. Drama. Did it not open? There it is. Wow, okay. Whoa, that's loud. Not playback speed, I want volume. Where's my playback volume? Okay, close, no. Playback speed 1, okay. Where's my volume? It feels loud to me. Very loud. Gain -5. Oh, pan. I feel like -12 feels more like the other songs, so we can. Oh, the rate's correct. File, export. So this is piano. Okay. Countdown dramatic. There we go. Where's the selecting? Stop selecting. I don't know how I feel about this one. Close. Let's skip that one for now. Let's just Deck the Halls. Always a good one. Um, 44.100. Export. Okay. Educational documentary piano. Sure. 44.100. Export. Probably a way I could script this out, but it's fine. Even if we just have like 3 of these lists, that's probably enough for me to develop against. All right, we've got a couple of epic background orchestral coming up. Minus 15 dB maybe. Sample rate's correct. Export. Save. Okay. All right. So this one is Epic. Orchestral music, Rise of Legends. Probably minus 15 dB. Okay, sample rate's correct, and export. Nope, not that. Okay. So I kind of want like 3 or 4 of each of these flavors. Or more, it's fine. The sample rate's not right. There it is. That's the one we want. Could we support multiple sample rates? Sure, but we're not going to. We're going to keep my development as simple as possible. So this one was Epic, this one was Epic, this one is piano, like calming piano. Okay. Forest Tales background orchestral. That's very loud. Sure, we can export that as sample rate's correct. This will be Halloween. Horror spooky piano next up. Okay. Sample rate's correct. Export as WAV. That is not the file I thought it was. Okay. I missed one. Funtime positive rock background music. Funtime positive rock background music. Sample rate's correct. Export. There we go. All right. Yes, this is. I don't know about rock, but it says it's rock. It's close enough. Inspirational, uplifting, calm piano. Okay. Sample rate's correct. Okay. Piano. Lunar Tides. I don't even know what that means. I can't remember what song that was. Lunar Tides. Ooh, it looks very loud. Let's minus 20 that, and then play. Synthwave. fine. Again, like, we don't really care what the songs are, as long as we can kind of theme them and hear what's going on. Okay, yeah, the sample rate is correct. So Lunar Tides is like a synthwave. It'll probably be in with a rock or something. Midnight Quirk. Looks a little on the loud side. Let's go -15. Okay, so groovy. Sample rate's correct. Export will have. We will call it rock, even though it's not quite right. Okay, Night Whisper. We've got 1, 2, 3 Christmas. We've got okay. Sample rate's correct. Export. This will be another Halloween one. Silent Night. Okay. Export as WAV is the correct sampling frequency, and it is Christmas. Twilight Tussle next up. That looks very loud. Let's go -20. Okay. We're going to call that rock. Groovy rock or something. Sample rate's correct. Export as WAV. And then We Wish You a Merry Christmas is next. Sample rate is correct for us. Export, okay. Christmas. Okay. Let's go put all the Christmas ones next to each other. Christmas. We got piano. We got 5 Christmas. 3 piano. Let's go ahead and put Halloween up here by Christmas. 4 Halloweens at least. That was a synthwave. There we go. Synthwave, piano, piano, epic, rock, piano. Okay. So here's the thing. We have a playlist with 1 song in it, a playlist with 2 songs in it, and then, N. So that's why we have these things. We'll check the dates for Christmas and Halloween. Otherwise, we'll use what is appropriate here. I think that's basically that. So let's go up to here. I would like to see like length. Those all look okay. Okay. So let me dump those into my music folder. Word Sleuth, assets, sounds. I want to put in a new folder called music, and hopefully all the relative folder stuff was coded up reasonably intelligently back in the day. Let's see, this one. Move. The one we don't want is the countdown dramatic. So let's remove that from our list. Oh, we never exported it. Perfect. Good. Okay, so part 1 is done. No, and all right, we're done with the Audacity. Assets, sounds. We want all of these, but MP3. So, or WAV. Done. Okay, so this will be we're gonna put all these at like half volume to start with. We need a name though. Let's see here. Carol of the Bells.wav, which is music, which is at 0.5. // assets, sounds, music / there we go. We're gonna do that. Oops. Okay, these are not all Carol of the Bells, obviously. So this is Christmas party time. Silent night. We wish you a Merry Christmas. Deck the halls. Forest tales. Spooky piano. Night whisper. Lunar tides. Cinematic, dramatic, sad piano. Let's see here, piano drama. I guess I don't know. Oh, that was Lunar Tides. Then what was this one? Countdown dramatic? Oops. Dramatic countdown. Piano drama. Documentary piano. Evening glow. Ode to joy. Oh, rise of legends. Fun time positive rock. Positive rock it is. Oops. Did we get okay. Ode to victory, by the way. Victory, uplifting, so calm, piano. Midnight, work, and twilight puzzle. Okay, so that's all of our audio. We're gonna embed all of that. Oof. Nope. My bad. There we go. Now we're going to cd tools bin./embed WAVs. This could take a minute, and our files are going to grow quite a bit with all this music. So like if we word count our warehouses again, word count -L. That's the one. Could not read file countdown dramatic. Oh, that's fine. Everything else should be in and working. Daddy. Just a moment. All right. So in sounds, we need to get rid of that countdown. I don't think we're using it. Dramatic countdown now. Let's run that real quick. Then we will word count how big the warehouse got. Word count -L. So our sound warehouse was 250,000 lines of binary data. After we put in a bunch of songs, we will see. The other thing I would like to do is associate the file name, the embedded name, and its key, because we're going to look at that. Okay. So that all worked. It was 223,000. And now it's 1,000,000 lines. Putting in that many songs added an awful lot of data. Oh wait, more than that? 10 million? The sound warehouse is now 10 million lines of audio data. Wow. That's a lot. Okay, but now we know. Probably Sandbox is where we need to be. I'm gonna do a full clean with all the new sound data in there. Probably not lining things correctly. While it's doing that, we're going to sounds.txt. We're going to songs.org. And we are, there's a way to, there we go. Get our key. Over here, put it in. Now we have keys for most of them except lunar tides, because countdown dramatic isn't a thing. So we're going to go back to lunar tides. Run it. There we go. There, we now have a list of names, keys, and the theme that we want it to be. Yeah, this sound warehouse is going to take a while to embed. And when we start up, we're going to see that our sounds no longer take a small handful of bytes, right? Our sounds were 6 megabytes. It's going to be a lot more now. Fun. So I think I don't know what I want to do yet. I could make a music player part of every scene, since every scene will have background music. Seems okay. Playlist. And a way to build playlists. Different playlists. If it's a holiday, different playlists depending on what scene we're in. I don't think the playlist should be defined by the scene, since we will be reusing some playlists across scenes depending on the holiday. Or we can mix playlists. It's going to take a while to compile. That does mean what does it mean? Yeah, that kind of kills our compile time. And I should never ever open the Sound Warehouse CPP file. Instead of 76 megabytes, we're looking at 350 megabytes. Woo-wee. Yeah, we are going to have to compress our data a lot. We can probably compress. I don't want to start the compression stuff, but it is killing my build times. That is going to be a problem. So that build took a while. I don't think we get a time finished. 15:24. Yeah, so that took almost 5 minutes. It took a little over 5 minutes. 5 minutes to compile. That means we don't get very fast iteration times. Okay. Oop, there it is. Initialize our sound test. Update our sound test. Application. Okay, so we need a music player. And I don't know what it needs to do yet. It needs a sound. Do we need to crossfade songs? Let's just start simple. I think in our case we have what, 5, 6 scenes and some special holidays. Playlist. Do I want a playlist object? Kind of. Set a playlist. Okay. Tools.o and a music player.o. Song with music player. I should compile those. So first I'm going to use a playlist. And a playlist is going to consist of some number of entries. We'll have Sound Warehouse asset. Title. These are all public. Nobody's going to be messing with this. They shouldn't. It's all hidden away. Okay. Capacity account. We also need an index, int underscore entry index. Assignment operator. We can't really do that. Can we do that? This is probably not the safest operation. We may want to delete the current title, allocate a new one, and then stir copy. It's probably safer that way. We need an destructor. We'll probably just bring all the default stuff. If underscore title not equal to null. Entry and other. Just do a simple assignment. If other.m underscore title is not equal to null. New character array of 9 plus 1. Stir copy. Other.m underscore title. I think it's destination first. M underscore title. I think. Okay, adding an entry. Just do this. What am I doing? What am I doing? If we have a title, we delete it. Otherwise, the title we're passing in is not null. We allocate a new title and copy. set other dot underscore asset. Underscore title. That actually simplifies nicely. Okay, when we got an entry. Okay. So basically we need an array. Shuffle. That'll be a very useful thing. Entry capacity. There we go. Okay. Read entries. That's basically it. Assert entry count is less than entry capacity minus 1. So we have a capacity of 4 and our entry count is 3. We can't add another one. So just assert that that doesn't happen. Add an entry. Easy. Shuffle. We'll come back to shuffle. Right now it's not going to do anything. Use a good old, what is it, KMP, Newt Morris Pratt? No. I think that's the text search. What's the Newt Yates shuffle? Okay. So I have a playlist. And we have a music play. What is this? Music player. Which needs playlist. Set playlist. Copy playlist versus use playlist. Cool. Playlist owned. I think that's correct. Null. False. So that doesn't do anything. Okay, let me delete. Yeah, underscore playlist owned. And underscore playlist. Not equal to null. Delete the playlist. That's basically it. Equals playlist. So in other words, we don't know the reference to it. So underscore playlist only equals false. We cannot delete it ourselves. Here, a new playlist from our current playlist. Playlist other. Or index equals underscore entry count equals 0 rather. Index less than count index underscore entries at that index equals underscore other entries at index. There, that's a copy. Copy constructor. All right, music player. Copy. So playlist owned is definitely true. Okay. anything else we need? We need things like play. We need to get the next song. So let's say playlist. There's a couple of controls. For playlist, we need a sound warehouse asset current song. Current title. Char star. We need void advance. And we already have shuffle as part of our thing. Okay. We need to ask, are we at the end? Bool at end. Are we at the end of the playlist? We have to decide what that means, so let's do this. Set CPP right before the shuffle, which we're not doing yet. We get a playlist. Current song. Playlist const. Playlist at end. Playlist advance. Okay. Advance, we're going to say underscore entry index. Just inputs. We're at the end if entry index is greater than or equal to underscore entry count. Current title. What I have here is if we are not at the end, result equals m underscore entries sub m underscore entry index dot something dot underscore. Why do we do that? That's fine. M underscore title. And then return it. Okay. Sound warehouse asset. Sound warehouse asset none. Turn result. Not at the end, we get the song, I think we called it. The underscore asset. Because the music player will handle everything else, the logic, etc., etc. Music player. The other thing we are going to need is an update function. If m underscore playlist is not equal to null, then we do things. Let's see here. Are we playing a song? Is the song done? Fade in and out. End of list equals shuffle. Advance. Fade in out. Is the song done in advance? We get to the list, then we shuffle. Start playing the next song. Fade in. If we're beginning or end. Start playing the next song. I think that's the general flow. Is the song done? Otherwise, advance. If we're at the end of list, end of list, then we shuffle. Start playing the next song. So when we create a playlist, we start at index 0. And when we say advance, okay, so underscore sound is playing. Fading out if we're near the beginning or the end. Oh, just let it play. We don't have to do the fade in and out right now. That's just where it's going to happen. Otherwise, underscore playlist, advance, underscore playlist, at end, playlist, shuffle. Sound set file. Playlist current song. Start playing. Prequeuing the volume for fade in out or fade in. There, that's basically the flow. Shuffle, then m underscore entry index equals 0. We start over. To do, make sure last song played is not in first this time. And maybe if we can, not first 1 or 2. Because if you hear a song, shuffle, do something else, and then back to the same song, unless there's only one or two entries, not the worst. Okay. In general, though, this is the flow for playing music. Update. So we're going to go to our sandbox scene. We need a playlist and a music player. DJ. Init and update. There is no render needed. Okay. Init and update. So we'll put it here. Oh wait, not this one. That one. There we go. Since compile operations have just become much more expensive, we're trying to get as much stubbed in and done as we can before we compile again, because that's 5 minutes of dead air or dead time. We will eventually get around to optimizing that, but for now, good enough, I guess. Okay. Set playlist. Oh, use playlist. Copy playlist. We're just gonna do that. DJ.update. That's pretty much it. So go playlist, playlist. And we're going to build up a little thing, songs.org. Let's do the rock, 3 rocks. Which needs 3 entries. Playlist, add entry, sound warehouse asset for positive rock. It has a title of something. Kind of doesn't matter. We just want to log it. Midnight Court. And Twilight Hustle. And that's basically the playlist. One thing we failed on, when we reset, we go to -1. Copy the address from playlist. Playlist.shuffle. We should always pre-shuffle before we throw it in. Actually, music player. Okay. Music player. When we advance, sound up play. From m_playlist, point to current title. Now playing. What are the odds all this works? Okay, this could take a while, about 5 minutes. Oh! And I very much doubt that it's without errors. So I will want to be very careful about doing clean and build. Right, playlist. Asset error. Oh, that's what we want. Okay, none. Stir copy. Okay. No return statement. Okay, we saw those before. Oh, sound warehouse. So playlist. Bunch of those. Asset, blah, blah, blah. Okay. Playlist needs sleep stream. Copy constructor and oh. Oh, now I have to wait for the sound warehouse. Hundreds of megabytes of data to get compiled. Where are we at? 4 o'clock? I'm seriously thinking running a clean that does not delete the sound warehouse. Or the image warehouse. We're not really working, we're not modifying those. In batch, can I deliberately remove an option? Or in remove substring in makefile? Blast shell expansion. Must be escaped. $sign. $sign if you want to suppress the echo of the recipe. Put the at the beginning, not in the middle of the recipe. Also use make variables and functions. This is what I want. Pat subst. Yes, we should do this using those things. Okay. Because yeah, I don't want to compile image and sound warehouse over and over again. Which means the clean option needs like a small clean or quick clean. If we just tidy up instead of clean. And the trick here is I want to remove everything. Let's see here, bash, remove everything except two files. We can cheat easier. Let's just cheat easier. Why do this hard way? Tidy. Okay. If soundwarehouse.o then I think we do this as a one-liner like this. This is a file. Then oops, do things then fine. We're going to move soundwarehouse.o to soundwarehouse.temp. Then if.temp, move it back to O. Same thing for image warehouse. So basically, if we have those .o files, we save them off to the side, delete everything else that we need to delete, then put them back in place. Checking our compilation file, we will tidy and debug. Now, we should rebuild everything except the sound warehouse and the image warehouse, in theory, which should not take 5 minutes. Because they're huge. Okay. Yeah, this is going to go much faster then. Oh, we still have a none in there? I thought we got rid of those. Error. Return is misspelled. We can't type. I thought we fixed that so that it, oh, let's see. No return statement. Oh, because we misspelled return, so that's fine. Okay. I don't have to do anything except test it. So we told it, here are 3 songs. And go. Now we're not shuffling. We're not doing fade in and out on a song. That will all come with time. Source builds debug. Okay. There's no holiday today. We sandbox. We declared init music test and update music test. We aren't actually calling them. Init music test. Update music test. Okay. All right. Assertion failed. Entry count less than entry capacity minus 1. I think I know what that's about. Assert. Yep. Off by wonder, always fun. Basically, we can put something in there and then advance, then check for if we're at the end. Advance. And we're at the end. Shuffle. Set our file and go. Okay, it is dying. Critical error detected. Init music test. Playlist 25. This is as we leave the scope of init music test. So sandbox scene 1089. Saying give me 3. And then it's crashing on line 25. That's the destructor. It shouldn't be called. All right, let's do this then. Okay. No more warnings. And debugger in case it crashes again. Critical error. RTL is 0 memory. The destructor of playlist at 1089. We're not calling a destructor at this point. Thank you. Right, we're doing a fork clean then. Which means we're gonna wait 5 minutes to do the test. All out of water. Okay. While this is building, I'm gonna use a quick restroom break. And we'll carry on when I get back. Just a minute. Okay. Where are we? Still going. I was afraid of that. That old sound warehouse really, really kills our compile time. If I cut our sound embedded data by a factor of 4, that would be kind of cool. I'm not really ready for the optimization stage though. I'm ready. I'm ready. I just don't want to do it yet. Not until I have to. Or not until I've really run out of things to work on. Like, this is the very last step, is optimization. Because once I optimize it, things might become harder to read. The way I do things changes a little bit. It's just lots of possible development nightmares can happen. Sound itself, its tag. I think I need to store the sound's initial volume level. And then scale it. But none of that matters too much just yet. Ooh, okay. Critical error detected. Okay, so this isn't a problem with the way we're building. NTDLL Microsoft Visual C runtime. I hate init music test. $10.89. Why is it calling it destructor at this point? RTL preheat. It's blowing up inside the destructor for playlist. But we haven't gotten to the point where a destructor is even necessary. What is it doing? There's no destructor to have. It's the constructor that should be called here. So what is it even doing? Because it's telling me this. It's being called from this line. That's what my call stack looks like. Unbelievable. What is my compiler doing? What would be this? You just use the playlist. Then we become the owner. We should not need a full rebuild. Oh, they're gonna fail though. Okay, why? What is wrong with that destructor? It makes no sense to me. Oh, good heavens. Oh, okay. We're playing. Fun time, positive rock background music. Now, if we wait, this song will end in a minute and a half or so, and then it should automatically start playing the next one. Okay. Music player. Playlist is null. Playlist owned is false. If we say copy, I don't know. Okay. Okay, this song will fade out, and it should just fire right up the next song. Midnight Quirk. Again, we're not shuffling, but it is all working. Now we gotta wait a minute and a half for this one. We want to make sure it loops and claims to shuffle. Okay, so Midnight Quirk is over. Twilight Tussle. So our music player is advancing through the songs. I don't remember how long Twilight Tussle is supposed to be. What was it called? Twilight Tussle. Oh. And that fails. Okay. That's a minute and 4. Okay, so expression index between. Okay. Set assert. Oh. Advance. If we are not playing, you just have to check before and after. Can we speed up the running of time? Sandbox. Time. Scale. Okay. Let's speed up how fast the music plays so we don't have to listen to it. Update music test. So our sound already scales with our time scale. It won't sound normal, but you know, whatever. And we can in later make this music load its sound without time scaling. We're going to force time scaling for now so we can test faster. Okay. So double time. Okay, song finishes, it goes to Midnight Quirk. Super exciting. Twilight Hustle lasts about a minute, so in this case it's probably about 15 seconds. Since we're scaling time by 4. Then it should loop back around to Fun Time Positive Rock. It didn't. So the sound warehouse is not getting a valid value. When we hit the end, oh. Okay, maybe I do know what's going on then. If we're at the end, we shuffle, then advance. Because the shuffle puts us back at -1. Okay. Let's try this. Okay. You know what we should do? We should probably make our music a little bit quieter when we're running so fast. Go back to sandbox. There we go. Now it's not quite so obnoxious, but I can still hear it. Okay. Okay, Twilight Hustle, 15 seconds or so, and it will either fail or succeed on the loop. Okay. So our songs will loop infinitely. Then Midnight Quirk. So we're not doing an actual shuffle, we just stubbed out the code around a shuffle. Overall, this is promising. Twilight Hustle, just make sure it loops one more time and we'll call it good. Yep. Alright, we have infinite looping. Perfect. That's probably a good place to save our work before we go on to the next things. We did that. Put out a basic music player and playlist in Sandbox. Loops a small list of songs. That's your nothing fancy, no shuffle. Not convenient place or playlists. Yeah. All still a little bit on the manual side of things. All right, add everything. We can probably remove the doc songs though. Yeah, this good old Sound Warehouse is huge now. So this might take a few seconds for Git to handle. Okay. Okay. Restore staged doc songs. First pass at a music player is looping a list of songs and logging the song names in Sandbox. Okay. Oh. Unable to generate diff stat. Does that mean it didn't happen? I'm okay with all that. Okay. It's committed now. Over to Old Journal. We need to do shuffling and fade in, fade out. Let's see here. Actually, here, play a list of songs one after another. That part is done. That may still hate me. That's okay. Old muscle memory that gonna drink. Okay. Sounds good. Yep. We should do song fade in and out next. Music player. What information do I have about a sound that I can use? I can say play, pause, stop, reset, sample rate, and hit cleanup. I think I can get my duration and the elapsed. Okay. Fade time equal let's go with 5 seconds for now. M_ sound. Let's see here. Elapsed is less than our fade time. Set file. Set volume, given the sound warehouse is fine. Okay. Get the volume out that way. All right. The one thing the music player needs is volume. I'm going to set our target volume there. Set volume to what's it called? Animation. Animation interpolate. The value elapsed over fade time. Let's see here. Let's just make this a little bit more automatic-y here. Put t equals elapsed over fade time. Using curves in just in case that's what we want. Go straight for plotting out. I don't know that it'll matter that much. Animation interpolate. T from start to end. Okay, so T from 0 to volume. Set volume to V. So this is fade in. Oops. M_sound dot set volume to 0. So we save out this target volume, then we set our current volume to 0. If we're in the first 5 seconds, we slowly ramp up that volume. So that should fade in. Oops. And I set it to like 5 seconds, so you should be able to hear it ramp up from 0 to whatever. Is that sped up? Just want to make sure it fades in. I think a lot of songs are going to fade themselves out. But not necessarily. Can't really tell. That song kind of started itself in a fade in. Okay. Fade in appears to be working. Fade out. Underscore sound dot duration minus underscore sound elapsed. If that's less than our fade time, we're in the last so many seconds of the thing. So if we're at, 1 minute duration minus 55 seconds elapsed. What's this at 5? All over fade time. We do want to go from volume down to 0. P equals the same thing. And between 0 and volume. So we do a little fade in, fade out. Okay, a couple more things we will need to think through. So journal. When leaving a scene, fade song out quickly and wait for it to be done before moving on. We don't want a song to just like cut off while we go from scene to scene. That's one thing we'll want. Okay. Let's see if the fade out works. A little shuffle. Okay, that built up nicely. I want to make sure it fades out though. Fade songs. Oh, well, assertion failed. My easing curve did not get a valid value. Duration minus elapsed. Duration minus elapsed is less than fade time. I mean, I guess we can clamp it. If t is less than 0, t equals 0. Because if my elapsed is longer than the duration, because last frame it was running, this frame we update our time, and it's past the length of the duration. So I think that's what happened there. We just clamp that end of it, should be fine. Question mark? Okay, actually, you know what? Firstly, sandbox. What's going on with my sandbox? Underscore button back. Render. Where is it? Text color. 0, 0, 0. I just can't see it, maybe. So to crossfade, all we need is 2 sounds and a flip-flop. Say this is the current sound. And we just run that same fade algorithm over both. We have volume 1, volume 2. I think we're gonna have to load up one of the piano songs or something. Fades out. Next one fades in. Hard to tell if there's much of a fade out there on that song. It already fades itself out. Four, 5, 6, 7, 8, 9, 10, 11, 12. Should be close to done. Again, it probably fades itself out plenty. Okay, so fade is fine. I'm guessing. I'm gonna turn the sound up just a scotch on the music. Okay. Now, we'll change our songs. Here's one playlist option we have. The other one was there we are. Let's get piano. Yes, there were 4 of them. Okay. Playlist, add entry, found warehouse, asset. There, now we have a new playlist. Here's the thing we will want to test. What if we don't fill it all the way up? Playlist should do something intelligent there. If we advance, while we are not at end, and we're going to do while not at end, and current song not equal to sound warehouse asset error. Music player. First we advance, then we check for the end. Okay. Where is set playlist? Use playlist. Assert playlist. I guess we need a way to report that, don't we? Length. Entry. Length is greater than 0. There's no reason to do anything unless we should not be getting empty playlists. Okay, that should fix most of the issues. What? Oh. Yeah, I agree. That should be int. What? Oh, we typed void twice. And we put it in the wrong place. There we go. Oof, okay. So we need sound 1, sound 2, volume 1, volume 2. Yeah. Hmm. Oh. And the current song is equal to error. If we haven't got a valid asset, cinematic, dramatic, sad piano drama. I don't know how long this song is. But basically, we said there were 5 things, but then we only set 4 of them. It should still work. There are 4 songs. Let's just see what happens. Ooh, that's another one thing we want to try. Can we set one of these to not scale with time? We don't want to experiment with that yet, actually. Make sure it loops on. It should. And back to the first. Yep, did not crash. Good. Okay, so. Dun, dun, dun. Do we want to crossfade and then work on the shuffle? Let's do the crossfade. I don't think it'll be that hard. It won't be trivial. Well, it shouldn't be that hard either. Sound 1, volume 1, sound 2, volume 2, bool, m underscore, sound. If sound 1 is playing, okay, so let's do this. Let's fade. Let's break this out as a separate function. Fade. We need a sound, and that's it. Basically do that. Oh, we need the target volume. 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 Which we also need to change. Volume underscore volume 1. If sound 1 is playing, we do the fade. Here's the deal. If we start a fade out, we need to know so that we can start the next thing. Let's make sure that volume 1 and sound 1 work as expected. Make sure we didn't break anything too badly here. Fade. Sound pointer and float star. Float reference. It's right there. What? Music player fade. Sound pointer. That's the problem. Not a reference. Syntax is dumb. Music player fade. Pointer, not reference. There we go. Okay, so let's make sure that that works as expected. Then we'll do the crossfade. Yep, seems good. Okay. I'm not even sure that we need this. No, not that one. Yeah. If sound 1 is playing, we do the fade. If sound 2 is playing, then we fade that one. music player. Void start. We need the sound start next. And we need the float volume. Sound one with sound one dot with sound put two, 1, 2, 3, 4, and underscore volume 1 with contents of volume. If underscore sound 1 is playing, not playing, and neither are playing. Let's do it that way. Sound 2 dot is playing. Neither are playing. Then we start next sound with m underscore sound 1 and underscore volume 1. So that should do that. And the last question is, if we're fading out, then we should start the next song before we're done fading out. Okay. All right, so start next is technically working. Fade. If we are fading out, we want to know what sound we're working on at what volume. We just do it with a flip-flop, like bool is sound 1. Maybe that would be easier. Is sound 1 sound 1. Okay, so when we're fading, everywhere we're sounding, so sound star SMD equals, is it sound 1? We take the address of underscore sound 1, otherwise take the address of underscore sound 2. And then our volume Volume 1, Volume 2. Address of Volume 1, address of Volume 2. Okay. If we are fading out, then we say start next not is sound 1. So let's say fire off the next sound. Is that it? As part of fade. If neither is playing, then do that. All right, let's see how that goes. No matching function. I agree. Fade true. Fade false. Start next. True. Well, this inside of an else. I'm not sure we need to. All right, let's see if we got crossfade. One's volume should go up while the other's going down. Oh, that's probably we need to probably tidy and then debug. Oh no! Oh darn it! Darn it! Oh no, that's fine. I was getting confused. Okay, carry on. One thing we may want to do is assert sound is playing, is not playing. That's a thing we may want to assert. $5:30. Okay, so we're probably have to do shuffle tomorrow. It's not that big of a deal. Shuffle. Okay. So the first one fires up. We want them to cross each other at the end. Assertion failed. Sound is not playing. Interesting. So, if we're fading in a sound and it's, say sound 1. Then we fade, and if we're fading out, oh. So the assert is actually bad. Because one frame we're going to come through, we're going to say fade, oh, we need to start the next song. And then the second frame will come in, we're still fading, and it'll still fire off that next song. So we need to start next only if the other song is, so if is sound 1, and I'm going to score sound 2 dot is playing. Or vice versa. Or it's not sound 1, and sound 2 is not playing. Sound 1 is not playing. Then we start the other song. All right, let's try that again. When we do those asserts, it tells us when we're being silly. In a way that you have to address. You can't move on without disabling the assert or fixing it. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a minute and a half, so 90 seconds. Okay. So they're crossfading. Maybe we get a little bit more. Now playing is sound 1. Okay. Let's just see that it is actually flip-flopping the songs, which we can do at full speed. $90 seconds, 45, so it's about 23 seconds. Playing 1. Two. Okay. So crossfade is working, fade in, fade out is working. We should probably save our work there. Song fade in, fade out, crossfade. shuffle. So each scene will load its own list. Then the special day list, which we will get to. Some player controls. Do I really want player controls? Not really. Most games don't let you like skip song or whatnot unless it's let's not do that. Let's play this current song title. I do kind of want to do that. I don't know where. Leaving a scene, fade the song out quickly. Yeah, so that's going to be a thing we have to do. Shuffle list. We have time. A Newth shuffle is not that hard. Okay, so songs now fade in and out over 5 seconds. Tested, uninitialized, songs in playlist, works like a champ. Now have 2 songs that cross fade. Good enough. Add everything. Explore stage doc songs. Okay, add everything. Get commit. Songs fade in, out. Songs crossfade. Cool. All right. Shuffled list. So here's the question. I don't have a way to say what file were you set with. Okay, so we do track this somewhere else. Music player, which is fine. Sound warehouse, asset 1, and asset 2. Set the volume. Pointer to an asset equals. Asset 1, asset 2. Okay. All right, now we're getting here. We're gonna say the contents of asset equals set file. So it's actually this thing. Contents of asset equals the current song. Then we set file equal to the contents of asset. Then we set our volume. Okay. So now we have the asset itself. When we advance and we shuffle, we want to pass in the last asset played. When we say shuffle, sound warehouse asset last asset played equals. Oh, you can initialize those. That's fine. Asset 1 equals error. Two. Actually, interestingly, when we start one, we want to set the other song's asset. I actually do want to flip-flop those. So if it's sound 1, we don't send the asset 1, we send asset 2. And if we're in asset 2, we send asset 1 to say this should not be the first thing in our shuffle. Okay. Playlist CPP shuffle. Oops. Okay. All right then. New Yates shuffle. Oh, Fisher Yates. See, it was a new thing. Whatever. Let me throw that in the old chat for those interested in shuffling. Fisher Yates shuffles. Okay. It's not too hard. A of n elements. The code original shows the rate in the opposite direction from lowest to highest. I like this one. Okay. So we're just going to steal it straight up. We can even properly attribute what we're doing. Because that's fine. For int index equals 0. Index less than n minus 1. N minus 2 plus index. Equals some random integer, which we're going to deal with here in a minute. U are in G. Dot next between I and N. M underscore, oh, it's not M minus 2, it's M underscore entry count. Entry count. Exchange A and I. Right, create a new entry. E equal or temp equals M underscore entries sub I entries sub j equals entries sub I up to j and underscore entries sub j equals temp. Okay, now that is the Fisher Yates shuffle. Or Newth Yates. I always heard it attributed to Newth. Newth. Yeah, let's do the Newth shuffle. It's like Newth Fisher Yates, I guess. Alright, whatever. To do, make sure The last song played is not the first in. If last asset played equal underscore entries sub-zero dot underscore song. I don't know what I call it now. Asset. If those are equal, we must move it. Which is basically this. Oh, well, depending. So this all works well and good if we have 0, 1, or 2 items. That's fine. This one only matters it's not in the first position. So this only matters if we have more than one entry. If underscore entry count is greater than 1, we do this. Int j equals the next thing from 1 up to entry count. So if there are 2 items, we'll get a random number between 1 and 1. 1 and 2 not inclusive, which would be 1. Then we swap. So we'll have to test this on like 1 and 2 playlists, which isn't too hard because we already planned for that. We'll try it first with a short playlist. We did not set up our thing. Okay. Game scene. Abstract RNG with GB flip and a uniform. There we are. So that goes into playlist. URNG playlist. URNG. RNG. Okay. So I get seated once. So it doesn't double play. Actually, all of this only matters if our entries are greater than 1. I was not declared. Oh, sub index. Index. Temp was not declared in this scope. Let's see here. Okay, almost there. Now, shuffle. We do a playlist. We don't have a last thing. Okay, playlist.cpp, shuffle. We should just have a default, right? Equals sound warehouse asset error, which should never match anything. Okay. I think I'm going to do a tidy and debug because we did add the asset fields. And now it should loop, but never repeat a song and never play them in this, not necessarily never play them in the same order, but yeah, it should be very unlikely. So listen through a couple of loops and hope it just works, right? One other thing I want to do, I don't know if I have time though, is to play with the time sensitivity of the songs. So there's a thing called use scaled time. Because we don't want the songs to scale with the rest of the game. We don't really. Oy, it died. Segfault. Use playlist. Use playlist. So using a playlist. We assign our playlist. And say shuffle online 80 music player 33. It's right here. Playlist. Line 85. Why would that crash it? Unless, and this is something I don't remember, uniform RNG. Next, high minus low plus low. So I don't remember if that's inclusive. So if we do from 1 to 3, that's 2 plus 1. It would be inclusive, therefore minus 1. If I remember right, the shuffle could put things back in the same index. Okay. Okay, compile. We don't need to do a full tidy anymore. Just the one time we needed to do it. All right. Nope. Segfault. Set. I don't know why. Hmm. If index not equal to j, we don't have to do anything, right? Maybe it doesn't like that we're trying to assign to ourselves from a const. That could be. I suppose it's possible. And it dies. Hmm. Oh, that time it worked. So we're gonna run this all the way out and see what happens when we loop. I don't think anything shuffled. Which is why it succeeded. Okay, Twilight Hustle, blah blah blah. And it's gonna fail on the shuffle, I'll bet. Which means we just got lucky this time, and there it died. Backtrace. Entry set. what happens, line 52. If title is not equal to null, so I'm going to store title equals null in our constructor. Title should only ever be assigned to a real thing or null. Title, oh, right here. Ah. Now set. We should be fine. Okay. Hey, Pat, better late than never. What's up, brother? Glad to see you're still on. Yes, I am still on, technically. Not for too much longer. I'm just trying to wrap this thing up. We are doing music playlists, and we just did some code to see what holidays we've got. Like, check this out. Global get holiday. We check for all the good ones. Valentine's Day, St. Patrick's Day, Independence Day, Talk Like a Pirate Day, Halloween, Christmas. Those are the easy ones. November's a little trickier. We have to say, are we on a Thursday and are we in the 3rd to 4th week range? Which isn't too bad. But then you get to Easter, man. Easter blew my mind. It has to do with both solar and lunar calendars, and then you shove that all into the Gregorian calendar and forget about it. But it's actually not that hard mathematically. But, why are we doing things with 19? I don't remember. I don't know. What do these numbers mean? I don't know. But it's fine. It works. It gives me an Easter every year we test it against. So that means we'll be able to choose our music playlists. Yeah. It's weird. I didn't realize there was an algorithm. I thought I'd have to go check a fixed list somebody else had already computed somewhere. But the algorithm's not that bad, so I've seen worse. So I've got 3 songs in a playlist. It should shuffle them. Right now, the first song wasn't moved, so that's not proof conclusive. We do crossfade our songs, so that's fun. See, it doesn't look like it shuffled them. We'll see what happens when we hit the end of the list. We got 3 songs. They take, 20, 30, 20, 15 to 25 seconds each at quad speed. They sound really funny at quad speed, though. This is not good music at these speeds. Okay, so it did shuffle. So the rule was, you shuffle, you cannot play the last song again. So it's not. And at the end of Midnight Quirk, what do we get? We'll get Twilight or Fun Time Positive Rock. Okay. So then that means we have to get Twilight Hustle for the last song again. And then it should reshuffle again at the end of that list. So it looks like the first shuffle isn't doing anything. And maybe that's just because we're lucky. So Twilight, Midnight, Fun, then back to Twilight. And then I don't know if it'll be Midnight or Fun times next. Okay. So it'll loop forever and never repeat a song. Yeah. So they're not playing in the same orders. Cool. Quit. Phew. That's good. That may be where we have to call it though. Let's see here. Sandbox. We do want to test with a 2 and 1 song playlist. So we should at least have those stubbed out for testing tomorrow. And our 2-element list is epic. So it's Ode to Victory and Rise of Legends. Which I don't remember the names of the files. We just steal them out of our document. There's a 2-element playlist to make sure shuffle doesn't break anything. Then we need a 1, which I think is our synthwave. So Lunar Tides is our synthwave song. So I'll be testing for tomorrow, but that's a good place to be. There, just for tomorrow's testing. But it is working now, except for the first shuffle. So, journal, where do we leave that? Shuffled list, sort of. Shuffle is mostly working, not the first time though. It should. Maybe we just got unlucky. Let's go run it one more time. Just to see. Nope, that's Fun Time Positive Rock again. But I know we are, so it's like in Sandbox, where we load up, we say use the playlist, music player, use playlist. We assign the playlist and then we shuffle. So that should do it. But that's not happening here. Okay, so launch it one more time. Fun Times Positive Rock again. Why is that first shuffle not doing anything? Hit that quick again. Okay, so it looks like it is true. It does not shuffle on the first time. Use playlist. Music player should shuffle it. Huh. Interesting. Okay. So journal. Shuffle is mostly working not the first time though. Unclear why. Test. Oh, we'll debug tomorrow. Also, test 1 and 2 song playlists tomorrow. Oh, wow, come back. There we go. Yeah, and then each scene can learn its own playlist. And then we have the special days list. So I've got a couple of Christmas and Halloween songs, so we can test against that to make sure that the scene playlist is overwritten by the special day list. Yeah, we're actually in pretty good shape for this song. It's pretty good. Not bad. Ooh. Yeah. Alright, so let's take a work. Get status. Get add everything. Commit. Oh, nope. Get restore. Stage. Docs. Songs. We don't want to check that in. Get shuffle mostly working. Except first playthrough. Needs more testing. Nice. Okay. Well, Pat, I'm gonna have to bounce now, but thanks for dropping in, even if it was late. Always better late than never. Tomorrow we'll keep going on the song thing. Yeah, wrap up these two things. I don't know about this display current song title. Let's take it out. Let's not do it. Then we have to fix when we leave a sing, fade the song out real quick, and don't proceed until it's done. So yeah, those are items for tomorrow. First scene playlists. And per play mode list. Game scene. Override playlists with special day list. I would holiday. Playlists. Fix, shuffle, fix, or finish shuffling playlists. All right, that's it. That's the story. There we go. We're done. Glad you got music implemented. Yeah, no worries, man. Hit me up later. Sounds good. Yeah, music technically implemented. These are not the final songs at all. They're just placeholders, so it'll be great. Yeah, I'll hit you up later, and you have a wonderful evening. I gotta get going, so have a wonderful evening. Bye bye.